Father, and of the Son, and of the Holy Spirit.
Amen.
Father in heaven, I would like to thank you for this wonderful day. I'd like to thank you for everything you've done for us. Father, as we are going into this lesson, Father, help us understand. Provide us with the gift of wisdom, knowledge, and understanding. Help us learn whatever we are going to study. In Jesus' name I've prayed.
Amen.
Amen.
Amen. Amen. Amen. Thank you so much. Thank you. Members, the last time we met, we were looking at indices, and we have discussed indices at length, and there's nothing that we have left that we have not looked at under indices. Not so? Yes? Are we together? Members, are we together?
Yes, teacher.
Yes.
Yes. So we have already learned indices. I just want us to do some 1 or 2 recaps, and then we go and look at our topic for today. Let's just do some few questions. More examples. Let's just put it under more examples. And at that time, when I was not around, I gave Teacher Joseph to give you some work, and he told me he has given you. And I believe you have discussed it in your groups and you have understood whatever you have discussed. So I don't want to take a lot of time on that, because that's what we were supposed to do last week. I believe people have done the right thing. Not so? Yes, members, not so? I believe you have done the right thing. So let's write this question down. Let's write this question down. Number 1, solve for the value of m. So I see that we have 4 times 2 raised to power 3m minus 3 equals to 2 to the power negative m. To the power negative m. The question is solve for m. Solve for m. So what are we going to do in this case, members? We said when you are solving equation involving indices, the first thing is to make the numbers to the lowest base possible. Then after reducing the base to the lowest base possible, then you apply the law of indices. So we must remember laws of indices, and then we apply them accordingly. We reduce them until they have the same base on both sides. We say same base on both sides. That's what is the most important there. So let's go and look at that. So we have 4 times 2 3m minus 3 equals to 2 to the power negative m. So you find that the one with the largest base here, we have 2, but the one with the largest base here is 4. So you have to find a way of simplifying 4. You have to find a way of simplifying 4. You come and say, but we know that 4 is the same as 2 squared. Is the same as 2 squared. So which means I'll have 2 to the power 2 times 2 to the power 3m minus 3 equals to 2 to the power negative m. So when you look at in the right hand side, we have only 1. We have only 1. So which means the work we have to do is to simplify this until I have the same base. So now when you look at this, they have the same base and we are multiplying. So when you recall, I said when I have a to the power m times a to the power n, what we do, we multiply. We add. When we are adding the numbers, what we do, we add the powers. So this will be m plus n, like that. So if that is true, so which means it implies that now here we shall have 2 into 2 plus 3m minus 3 equals to 2 to the power negative m. So when you simplify that, we shall have 2, 2 minus 3, so this one will give us 3m minus 1 equals to 2 to the power m. So you see now they have the same base. They have the same what? Base. So what we do, equate the powers. So equating powers equating powers. When we equate their powers, we shall have 3m minus 1 equals to negative m. So after that, collect the like terms. Collect the like terms. So when you collect the like terms, you shall have 3m. This one, when cross the equation become a positive, so become plus m equals 1. And then this one, this negative one, when you cross the equation become a positive. Become a positive. So which means we shall have 4m equals to 1. So divide all through by 4, divide all through by 4. This and this will go away. Therefore, our m is equals to 1 out of 4. Members, are we together on that? Are we together?
Yes.
Good. Good. That is number one. Let's add one more, and then we go and look at our what we prepared for today. What we prepared for today. Number two. Find x if 4 to the power 2x minus 1 is equals to 1024. Is equals to 1024. So we do the same way. We have to simplify this one until they have the lowest possible base. You can see that 4 can be reduced to 2 squared. What about 1024? Now you go for your side work. Side work. We come here. Side work. We have 1024. So we decompose that by using the smallest or the lowest possible number, and in this case, the lowest possible number is 2. So we shall have 1024 divided by 2. It will give us 512. Continue. This one can be still divided by 2. Divided by 2. It will give us 256. This one can still be divided by 2. Divided by 2. It will give us 120. 28. 2 can still divide that. So divided by 2. It will give us 64. Continue dividing that by 2. It will give us 32. Continue that by 2. That one will give us 16. By 2. That one will give us 8. By 2. That one will give us 4. By 2. That one will give us 2. Then by 2. That one will give us 1. You can see that. So we can say 1024 is the same as 2. How many times are we multiplying 2 here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times, right? So this means 1024 is the same as 2 to the power 10. You can even see that. So when I put 2 to the power 10, 2 to the power 10, it will give me 1024. Members, are you getting me?
Yes.
Okay. So 1024 is the same as 2 to the power 10. So which means it implies now we shall have 2. We shall have 2 to the power 2, which is 4, which is for the 4. Again, raised to another power, which is 2x minus 1, equals to 1024, which we have calculated. We got 2 to the power 10. So now you see this one. When you recall, let me write recall. Recall. Yes, members. Hello?
Yes, teacher.
Yes, teacher.
Someone is disturbing me again with phone calls here. Sorry. So when you recall, I said if I have a to the power m, again raised to another power n, what do we do? What do we do to the powers? We multiply.
Multiply.
We multiply the powers.
Multiply them.
So which means it implies now we shall have 2 into 2x minus 1. I think that equals to 2 to the power 10. So if that is true, when you open this, this will give us 4x minus 2 equals to 2 to the power. Now you can see that they have the same base. So since they have the same base, equate the powers. Equate the what? The powers. So which means we shall have 4x minus 2 equals to 10. So when you collect the right term, we shall have 4x equals to 10 plus 2. So 4x is equals to 12. So divide also by 4, divide also by 4. So therefore, our x is equals to
3.
Our x is 3. As simple as members.
What?
Yes, as simple as that. So that's just a simple recap of what we have looked at the other time. Now let's go and look at Surds. Subheading Surds. Okay? Let's look at Surds. Surds. Members, we said a number which cannot be expressed as an integer, a number which now cannot be expressed as an integer, or a terminating decimal or a recurring decimal is called a rational number. So a rational number is a number which cannot be expressed as a recurring decimal, terminating decimal. Okay, that number is or an integer. That number is called a rational. Okay, irrational. So the one which we can express as a fraction. So another word for fraction, we can use fraction. Fraction is irrational. Another name for fraction is irrational. Excuse me, please. Is irrational numbers. So like 2 I can write it as a fraction. 2 is the same as 2 over 1. Okay? 2 is the same as 2 over 1. Like 4 I can get its square root, what we call terminating decimals. Like a square root of 4, I know the answer is 2. Okay, the square root of 16 is 4. So these numbers, all these one you are seeing them, they are rational numbers. So numbers which cannot be expressed as an integer, or as a terminating decimal or a recurring decimal is what we refer to as irrational. But the one which can be expressed as a recurring decimal, as a terminating decimal, or as an integer, those one we refer to them as rational numbers. An example of rational numbers, we can have like 2. Like we can also have a half. A half is a rational number. We can have a quarter. Those are rational numbers because they can be expressed in fractions. And they can be written as terminating fractions because when you press them, it can give us either a terminating fraction or a recurring decimal or as an integer. Okay? Are you together, members? So we know that when I get a square root of 4, a square root of 4 is either positive or negative. So we know what integers are. So those numbers we refer to them as rational numbers. Now, when we talk of surds fall under the class of A surd is an example of irrational numbers. But now for surds we shall be dealing with roots. For surds we deal with roots. Surds deal with what? Roots. So like a number, which number is that one which you cannot get even the square root? It does not give us a definite value, or we cannot write it as a recurring decimal. One of them we have is root of 2. Okay? Because like when you press root of 2, press like root of 2, you find that this number we cannot write it in fractions. We cannot change this one into fraction. Can we change this number into fraction? You can see, even if I want to change to fraction, are you seeing this symbol here? Are you seeing this one? So you press shift and that one, you see that cannot be changed. You cannot change it to a fraction. So any number that cannot be written as a fractional number, that number is irrational. And one of example of irrational number is a surd. But for surd, we deal with only roots. Are you together, members? We deal with what? Roots. Like the cube root. If you look at the cube root of 2, do we have the cube root of 2? You can press it, shift, cube root of 2. You find that if I'm to change this number to a fraction, cannot be changed. You cannot change it to fraction. I think that. Members, are we together?
Yes.
Yes. So
Yes.
any number under a square root, which we cannot get a definite value. We cannot get it a definite value, or we cannot express it as an integer. That number is a surd. Is a what? A surd. But it must be under a square root or a cube root. So anything, for surd we said we deal with only roots. So one of them we have root of 2, the cube root of 2. What about the cube root of? We can also have a cube root of 4. Okay? Can you get for me the cube root of 4? Cube root of 4. You see that you cannot put it in fraction. If you want to change it to fraction, you cannot change it. Still give you back the same value. Another one we can have square root of 11. So all non-square numbers are referred to as surds when you put them under the square root. Are you together, members? Are we together on that?
Yes. Yes.
Good. So we have root of 2, cube root of 2, cube root of 4, root of 11. You can look at maybe root of 13. Okay? Those numbers, when you press them and you want to change them, you cannot express them as an integer. So those numbers we refer to them as surds. Other roots such as root of 3, root of 11, cube root of 4 are examples of irrational numbers. Consider the following. When you look at part A, root of 4, 4 is a rational number. I think that 4 is a rational number. 27 is irrational because we can get it cube root. 16, we can get it fourth root. Root of 0.09, we can also express it as a fraction. So which means root of 2, root of 4, which give us 2. Then the cube root of 27, which is 3. Okay? Someone is asking, why is that the cube root may be 3? We know that 27 is the same as 3 cube. That one we know that. So, and we said when the number is to the cube root means is a third. The number is raised to the power a third. That's what we discussed at that time. So which means it's going to be 3 to the power 3, again raised to another power 3. A third, sorry. So it becomes 3 to the power 3 times a third, which will give us 3. That's why we are saying that the cube root of 27 is 3 because of that. So this one we can get its square root, we can get its cube root, which means this one fall out of surds. It become a rational number. The same applies to the fourth root of 16. We know the answer is 2. Why we're saying is 16? Why are we saying is 2? Because 16 is the same as 2 to the power 4. So which means if I put it there, so it becomes 2 to the power 4 again. at a quarter, which will become 2 to the power 4 times a quarter, which will give me 2. I see that. Then we also are saying we have root of 0.09. We know the square root is the same as a half, so which means I can say 0.09 again raised to the power a half. But this number can be expressed into fraction, not so. We can express this one as a fraction, right? So when you express that one as a fraction, is the same as 9 out of 100. It's the same as 9 out of 100 to the power half. Now, when you look at 9 and 100, all those are square numbers. So this one is going to be the same as 3 squared out of 10 squared to the power a half. Then we distribute their powers. We distribute their powers, which will give us 3 squared times a half, 10 squared times a half. Find this one, we'll go with that, so it will remain with 3 over 10. Have you seen that? Members, have you seen that?
Yes, we have.
Yeah, so this one is a rational. But now when we come to numbers like root of 2, when you have to see root of 2, it will give us 1.4141213.562. So this one we cannot change it. We cannot take it to a fraction. Can we change this one to fraction? Can we change this?
No.
I've already shown you how to change to fraction. When you press, you see it does not change. So which means root of 2 is a what? Root of 2 is what? Irrational. Even root of 5. If you look at root of 5, that one you cannot get its square root. When you look at the fifth root, I mean the cube root of 4. Cube root of 4. You find that we get 1.5874.01052. You cannot change it to fraction. You cannot change that. So which means this one is also what? Irrational. So that's what are we together on that, members?
Yes.
Good. So when you come back to the notes, we are saying we observe that in A, the numbers under the root sign are positive, which are rational numbers. And the roots of these numbers are either integer or can be expressed as a what? A ratio of the two integers. But in B, the numbers under the root sign are positive, rational number, but the roots of these numbers are what? Are irrational. So these numbers are called surds. Are you together, members? Are we together?
Yes.
So in a nutshell, we can say a surd is an irrational root of a rational number. So when they ask what's a surd is an irrational root of a rational number, because we cannot get their square roots. It does not give us a positive, it does not give us an integer, and the number that we get cannot be expressed as a recurring decimal or cannot be expressed as a terminating decimal. So that kind of number we refer to them as surds. Now let's look at, we have ways of reducing surds. Subheading, simplification of surds. How do we simplify surds? Subheading, simplification of surds. Let's look at how do we simplify surds. How to simplify surds. How to simplify surds. Part A, we have what we call reduced form of a surd. Reduced form of a surd. So we are saying, consider the following example. We have the first one, we have 72. So the number under the square root is rational. Remember that together? The number under the square root is rational. Okay? Now, when you want to simplify or you want to reduce this number to its simplest form, what we do, we think of two numbers. Think of two numbers that if you multiply them, must give you 72. But one of the numbers must have a square root. One of the numbers must have a square root. So you can think of which number is that? Which number should we multiply?
8 and 9.
Hmm?
8 times 9.
8 times 9 give us 70 what? 72, right? Not so. But now again, when you look at 8, 8 can still be simplified further. Okay, remember we are simplifying it to the simplest form. We want to simplify it into their simplest form. Okay? Remember? So when you look at 8, 8 can still be simplified. Because 8 is the same as 8 can still give us 4 times. Sorry. 4 times 2. But you see that 4 has a square root, not so? Not so?
Yes.
So we have to think we have to think of a number that one is irrational, then the other one has a square root. Because when you look at 8, 8 can still be simplified further. So let's look at the one which cannot be simplified further again after. So that number is what? 36 times
2.
36 times 2. Okay? Which will give us 70 what? 72. But now when you look at 36 as a square root, right? But 2 cannot, we don't have a square root for 2. I think that. So what you do, you come and say, it's like when we were looking at this one, recall, if I have a times b under the square root, this one is the same as root of a times root of b. Take note of that. If I have a number under the square root, it's the same as root of a. This one we are getting, where are we getting this idea from? We are getting it from indices. Okay?
Yes.
Yes. Where we are saying if I have ab to the power n, so it's the same as a to the power n times b to the power n. So in this case, our power is what? I have. So which is the square root. So what we do, which I'll say now, square root of 36 times 2. I think that. Which is equal to the square root of 36 times the square root of 2. Okay? If we simplify them. So what is the square root of 36? Is what? 6. Times root of what? 2. So that's the simplified form of 72. Are you together, members?
Yes.
Yes.
Yes, that is number 1. Number 2, you simplify for me 8. Root of 8. Root of 8 is the same as? Is the same
4
as?
times 2.
4 times 2. But root of 4 times 2 is the same as root of 4 times root of 2. Not so?
Yes.
What is root of 4? Is it?
2.
2. Times root of 2, it becomes root of 2. As simple as that. What about 45? What about 45? Who can simplify as 45? Think of two numbers that if you multiply, give you 45.
So can you repeat the
9 and 5.
Is 9 and?
9 and 5.
5.
9 times 5. So which means it will become 9 times 5, which will become root of 9 times root of 5. So this one, what will it give us? It will give us 3
3.
root of
5.
Root of 5. So leave your answer in Surds. Some will again go ahead and press root of 5 in your calculator. Here we are just simplifying. Okay? Members, here we are just what?
Simplifying.
Simplifying. So you can say in general, let's say in general, root of A times root of B is equals to root of A, B. Okay? Are you together? Then root of A times root of A. What do you get? Root of A times root of A, you get root of A squared, which is what? A. Not so?
Yes.
Good. Then lastly, I have root of A divided by root of B. So this one will be root of A over B when they're all under the same square root. Okay?
Yes.
Yes. Very good, very good. So now let's go ahead to example number 2. We have 4 minutes remaining. Let's go to more examples. More examples. The question is simplify root of 8 times root of 2. Simplify root of 8 times root of 2. Now, members, when you look at this one, when you look at this, please, who is writing on my work? Root of 8 times root of 2. Now, when you look at this one, can we simplify root of 2 again further? That one cannot be simplified further, not so?
Yes. Yes.
So, using this law we have seen here, root of A times root of B is the same as root of AB. Okay?
Yes.
Which is going to give us root of 8 times what?
8 times 2.
Times 2, which will give us root of 16. But root of 16, what is root of 16? Root of 16 is what?
4.
Is 4, right?
Yes.
Or this is method 1. Method 2, someone can decide to do it like this. You can say root of 8 times root of 2. Okay?
Yes.
Now, when you look at this one we can't simplify it further. So what we shall do, we shall just simplify root of 8. We know that root of 8 is the same as, you come and say, but root of 8 is the same as root of 4 times what? Times 2, right?
Yes.
So root of 8 will give us 2 root of what? 2 root of 2. Not so?
Yes.
So if that is true, so which means we shall have root of 8 times root of 2, which will now give us root of 8, which we said is 2 root of 2 times root of.
Times 2.
Now you see that this one they are the same, not so? This one are the same. So root of 2 times root of 2, that one is what? Is 2. So which means I remain with 2 times.
Hello?
I remain with 2 times.
Times 2.
0.20.
Some of you have not seen it. Let me remove it first. Let me first remove it. So we shall have 2. Now we multiply root of 2 times root of 2 will give me root of what? Root of 4. Which will give me 2. Root of 4 is what? Is 2. 2 times 2, which is it?
4.
Which is 4. Have you seen that? Have you seen that?
Yes. Yes.
Good. This is A. Work out B. Let's work out B. Let's work out B. In B, we have root of 12 divided by root of 27. So if we follow the other law, it's going to be the same as 12 out of what? 27, but under the same square root. under the same square what?
Square root.
Square root. So now what you do from there, you go ahead and simplify. By 4? Is it by 4 or by 3? By 3 we get 4, right?
Yes.
Yeah.
Then by 3 we get 9. So this one be 4 over what? 4 over?
Over 9.
4 over
Over
9.
9.
Which we can go ahead and also, we can go ahead and simplify that by getting the square root, the same as, it's going to be the same as root of 4, divided by root of 9.
Root of 9.
What is root of 4? We get 2. Root of
2.
9, root of 9 we get
3.
3.
as simple as
That.
that. Okay?
Yes.
Or alternatively, okay? Method 2, okay? Members, let me hope you are following me.
Yes, teacher.
What we can do is I say root of 12